Hello everyone. In previous class we have discussed about the basics of Kirchhoff's law. Today we will start with some numerical based on Kirchhoff's voltage law. Okay, so we will start with the first numerical. Calculate the current in each branch. Okay. Now, so first we'll put the name, let it is A, B, C, D, E and F. Now here you can see we have two different closed network. First like A, B, E, F, A, and another one is B, E, D, B, E, D, C, B. Okay. Now first we'll find the direction of current. Here this is the positive terminal of battery, so this will be the direction of current for this cell. Now here one more battery is connected, so this will be the direction. Let it is I1 and this is I2. Okay, at this point here one more current will move, let it is I3. Okay, again at this point where I3 is equals to I1 plus I2, because these two current will come at this junction and move in this direction, that is I3. So according to junction law, I3 is equals to at B, if we apply the junction law, this I3 is equals to I1 plus I2. Let this is our equation number 1. Now at this point again at E, I3 will split in two different parts. They are I1 and I2. Again at E, I3 is equals to I1 plus I2. The same thing. Now we will find out we'll choose the direction of calculation. So we can choose for first closed network, that is A, F, E, B, A. Either we'll choose the clockwise or anti-clockwise. Same, we are not bounded to take the same direction in this network. If in this closed network, if we'll choose the clockwise, here we can choose the anti-clockwise, or we will take the same in both the closed loop. Okay, it's totally depend on us, nothing is bounded. So first we'll solve the first network. So for apply Kirchhoff's voltage law in closed loop AF E B A. Let this is our direction of calculation. Clear? For first network. Now here as you can see, if we'll move in this direction, so our first this is the direction of calculation, like this, clockwise. Okay, so this will be the direction of calculation for this cell. Here it moves from positive terminal to negative terminal. That means first we will take 10 volt. Now current I, here as you can see, this is the direction of current and this is the direction of calculation. They are opposite. In opposite cases, what we used to do, used to take, that is minus IR. So minus I into 2, or you can say 2 I1. IR, V is equals to IR, so I into R. Current is I1 and resistance is 2 ohm. Okay, and direction is opposite, that means we will take the negative sign over here. For this resistance, this is the direction of current and this is the direction of calculation. They are again the opposite. Okay, if it is opposite, so we'll choose the negative sign. So minus 3 I3. Okay, now for this one, this is the direction of calculation. Okay, and this is the direction of current, that is downward. So again it is opposite. So we'll take I1 is the current and resistance is 1. That means we'll take the minus I1 is equals to 0. Or we can write 2I1 plus, okay, we'll shift this one towards right hand side. Here we have 10. Okay, so in place of I3 now we can put I1 plus I2. So plus 3 I1 plus I2 plus I1 is equals to 0, or 2I1 plus 3I1 plus 3I2 plus I1 is equals to 0, or 2 plus 3 5 plus 1 6 I1 plus 3I2 is equals to 0. We'll take 3 as common. So now what we have, 2I1 plus I2 is equals to 0. This is our equation number 2. Okay, now we'll apply KVL in another loop. So apply KVL in closed loop BEDCB. Okay, and we'll choose the same clockwise direction. Okay, so here we'll start from this cell. So here the direction of calculation is clockwise, and we are now in this case we are moving from negative to positive. So we'll choose minus 5. Okay, or the first terminal of battery will appear, that is negative. So it will be minus 5. Okay, here in this case it is 1. So the current is I2, that is the, here as you can see these two are moving in clockwise direction, means direction is same for this resistance. So we'll take positive, that means I2 into 1, which is equals to plus I2. Here in the case, this resistance current is I3 and this is the direction of calculation, which is same. So we'll take plus 3 I3, and for this resistance again the direction is same, means direction of current and direction of calculation are same. So here we'll take the plus 5 I2 is equals to 0. We'll shift minus 5 towards RHS. So here what we have, that is I2 plus 3. In place of I3 now we'll put I1 plus I2 from equation 1. So I1 plus I2 plus 5 I2 is equals to 0, or I2 plus 3 I1 plus 3 I2 plus 5 I2 is equals to, sorry, it is 5, or I2 314 plus 5 9, that means 3 I1 plus 9 I2 is equals to, sorry, here it should be 10, and we took 3 as common, so here it becomes 10 by 3. So 10 by 3. Okay, now here we have 5. Take 3 as common. So what we have, I1 plus 3I2 is equals to 5, or I1 plus 3I2 is equals to 5 by 3. And this is our equation number 3. Okay. Now we'll solve 2 and 3. So from here, I2 can be written as 10 by 3 minus 2 I1. We'll put this value of I2 in this equation. So here I1 plus 3 into, in place of I2, now what we have, 10 by 3 minus 2I1 is equals to 5 by 3. Okay. Now I1 plus 3 into 10 by 3 is equals to 10, minus 3 to the 6 I1 is equals to 5 by 3. Now here it becomes minus 5I1 is equals to 5 by 3 minus 10. We'll take 3 as LCM, so 5 minus 30, or minus 5I1 is equals to minus 25 by 3. Minus 25 by 3, or I1 is equals to minus 25 by 3 into minus 5, or I1 is equals to 5 by 3 ampere. Now we'll put this value of I1 in this equation to calculate the value of I2. Okay, so from equation 2, I2 is equals to 10 by 3 minus 2 I1, or 10 by 3 minus 2 into value of I1 is 5 by 3, or 10 by 3 minus 10 by 3, which is equals to 0, or I2 is equals to 0 ampere. Clear? Now from equation 1, I3 can be written as I1 plus I2, or 5 by 3 plus 0, or I3 is equals to 5 by 3 ampere. Clear? So this is the solution in of this question. I1, that is the current of this branch, I2 is the current through this branch, and I3 is current in this branch. Okay, so this is the final solution. Next question. Two batteries having EMF 10 volt and 5 volt. Internal resistances are 2 ohm and 1 ohm respectively. Are connected in parallel in such a way that they send current in same direction. Calculate current in each branch and potential difference across 5 ohm resistance. Okay. Two batteries having EMF 10 volt and 5 volt are connected in parallel. First we'll think in this direction. Okay. So we have two batteries and they are connected in parallel in such a way that they send current in the same direction. That's why we have connected the positive terminal of the two batteries are in the same direction. Calculate current in each branch. Five ohm resistance. I think something is missing. The external resistance current in the external resistance of 5 ohm in the same direction, sorry. Now, so if it sends current in external direction, in external resistance R, okay, 10 volt and 5 volt, okay, having internal resistances 2 ohm and 1 ohm. So we have to add internal resistance over here and value of R is 5 ohm, sorry. Now again this is the same as we have solved previous. A will take the name of the junction A, B, C, D, E and F. Now we'll choose the direction of calculation. In this one I will take, in first closed network I have chosen the clockwise. For another one we took the, or we take the direction that is anti-clockwise. Okay, so in apply KVL in closed loop AFEBA. Okay, so here this is the current I1, I2 and I3. So here I3 is equals to I1 plus I2. Consider it as equation number 1. Okay. Now, so first we'll choose this one. Here the direction of calculation is from positive terminal to negative terminal. So we'll take the plus 10. Okay. Next, here at this point, this is the direction of current and this is the direction of calculation. They are opposite in direction. So we'll take a negative sign over here. So minus 5i3. Okay, minus 5i3. At this point, this is the direction of current and this will be the direction of calculation, means opposite direction. So we will take again the negative sign, which is equals to 2i1 is equals to 0, or move 10 to towards the, or move these two over here. So what we have now, 5 in place of i3 will put i1 plus i2 minus, sorry, plus 2i1 is equals to 10, or 5i1 plus 5i2 is equals to plus 2i1 is equals to 10, or 7i1 plus 5i2 is equals to 10. Consider this as equation number 2. Next, apply KVL in closed loop BEDCB. Okay. Now, here first we'll start with battery. This is the direction of calculation, and this is, so we are moving from negative to positive. So here it is minus 5. Okay. Now, for this resistance, this is the direction of current and this is the direction of calculation. So both are in the same direction. So we'll take positive. That means plus I2 into 1, that is I2. Here in this resistance, this is the direction of calculation and this is the direction of current. Again both are same, so we'll take the positive. That means 5i3 is equals to 0, or minus 5 plus i2 plus 5i1 plus i2 is equals to 0, or i2 plus 5i1 plus 5i2 is equals to 5, or 5i1 plus 6i2, 5i2 plus 1, 6i2 is equals to 5. This is equation number 3. Now, to solve it, we'll multiply this equation by 7 or this equation by 5 and 6. So 6 and this equation by 5. Here it becomes 7 6 is 42 I1 plus 30 I2 is equals to 60, and 5 5 is 25 I1 plus 30 I2 is equals to 25. Okay, so I2, 30 I2 and 30 I2 will cancel out. Here we'll subtract it. So 17 I1 is equals to 35, and I1 is equals to 35 by 17 ampere. Okay, now from equation 2, so from equation 2, 7I1, so 7 into 35 by 17. Okay, the value of I1 is 35 by 17 plus 5I2. 5I2 is equals to 10. We'll take 5 as common. Okay, so here it becomes 5 7 into 7 upon 17 plus I2 is equals to 10 2, or I2 is equals to 2 minus 49 by 17, or I2 is equals to 17 is LCM, 17 to the 34 minus 49, or I2 is equals to minus 15 upon 17 ampere. Okay, here this negative sign shows the direction of current. That means if we took this is the direction of current in this network, so negative sign shows the opposite direction, means the actual direction of current will be in the opposite direction of the considered direction. Clear? Next, I3 is equals to I1 plus I2, or I1 is 35 by 17 minus 15 by 17, 20 by 17 ampere. Okay, next what we have to calculate? And potential difference across 5 ohm resistor. So here in this case, so we know that V is equals to I3 into R, because the current in this branch is I3. So 20 by 17 into 5, which is equals to 100 by 17 volt. 100 by 17 volt. Okay, so this is the solution of this numerical. You can try at your own. Okay, that's it for today. Thank you. Have a nice day.